We talked about switches previously in this module without mentioning the details of the functionality of the device. We now want to explore what a layer 2 switch is and how does it function. An Ethernet switch or a link layer switch is a device that performs store and forward of Ethernet frames in a layer 2 network. It examines the incoming frame's MAC address and selectively forwards a frame to one or more of its outgoing links. A switch is a transparent device. This means that the hosts and routers connected to the switch may not notice the involvement of the switch in the store and forward interactions. It is also plug and play. This means that switches do not need configuration to be able to perform the store and forward operations within a LAN. They start the operation upon connection to the network. Each host has a direct connection to the switch. For example, node A in the figure is connected to port 1 and node B to port 2, and so on. The links making these connections are operating full duplex. Each link runs an Ethernet protocol between the sender and the receiver, and each link has its own collision domain. This means that two different pairs of senders and receivers can transmit simultaneously without collision. However, one node cannot be involved in two simultaneous transmits. The packets sent from the hosts are buffered at the switch and forwarded on the appropriate switch port based on destination. For example, in the figure, we have 6 hosts connected to 6 ports of one switch, which is connecting these hosts in a LAN. If host A, that is connected to port 1, wants to communicate to A prime, which is connected to port 4, and host B, which is connected to port 2, wants to communicate to host B prime connected to port 5, these communications are possible concurrently without causing any collisions. However, A to A prime and B to A prime may not happen at the same time. On the same network example, how does switch know A prime is reachable via interface 4 and B prime is reachable via interface 5 to forward the frames to them? Each switch has a switch table. Each entry of this table has a MAC address of a host, interface to reach that host, and a timestamp. The entries to the switch table are created using a simple self-learning mechanism that we will explore next. A switch self-learns which hosts can be reached through which interfaces. The switch table is initially empty. When a frame is received, the switch learns the location of the sender from the incoming frame. It records the learned sender and the location in its switch table. The record remains in the table until the entry ages out. For example, if a frame is received from input port 1 from node A that is designed for node A prime, MAC address A will be learned for interface 1 based on the source address of the frame. This entry is then added to the switch table.